We're now going to talk about acids, bases, and salts. So commonly before you take chemistry class and you hear about, oh, acids are really dangerous and so forth. Well, acids are present all throughout your life. Most of the food you eat are acidic, and all an acid and a base are is just the way the molecules are made up of. And so we're going to go over some definitions of what an acid is, what a base is, and what a salt is. First definition that I want to go over is what we call the Arrhenius acid, or the Arrhenius base. From Arrhenius' definition, Arrhenius was a guy who studied, a chemist that studied acids and bases, and he defined an acid as whenever a hydrogen or a proton was present in water. So if something dissolves in water and it releases a proton, then it's called an acid. And so if we look at a formula and we see that there's a hydrogen that is ionizable, meaning the hydrogen can escape, then we call that an Arrhenius acid. So examples would be like HCl. And so most of the compounds that we encounter with a hydrogen as the beginning of the formula, we would call an Arrhenius acid. Now, Arrhenius base is a little bit different. Arrhenius base contains the hydroxide ion. The hydroxide ion is OH minus. So if your compound, your molecule contains OH minus, then it is going to be considered an Arrhenius base. Now, whenever we have an acid and a base react together, that is what we call a neutralization reaction. So whenever an acid base reacts together, it will always form a salt and water. The salt that forms is basically the ions of the acid and base coming together to make the salt. A salt is a metal and a nonmetal that have combined together, otherwise known as an ionic compound. So all ionic compounds are salts. Today, in your common language, we say a salt is sodium chloride. And that is a salt, but there's also other salts. We have magnesium chloride, we have potassium chloride, sodium nitrate would be a salt. So whenever you have an ionic compound, a metal and a nonmetal, or a cation and an anion combined together, that is what we call a salt. And that is what forms whenever we have a neutralization reaction, whenever we have an acid and a base react together. Now the other thing that forms is water. And what is water? Water is H2O. Now let's rearrange those elements a little bit, and instead of saying H2O, let's say HOH. The H comes from the acid, the OH comes from the base. And so whenever you have an acid that has a hydrogen and some nonmetal, or I should say some anion, and you have a base which has the OH, the hydroxide ion, along with some cation, the anion and the cation will combine together to make a salt, and the hydrogen from the acid and the hydroxide from the base will come together to make water. So whenever you have an acid and base combined together, you're going to have salt and water. So those are what we call an Arrhenius acid and base. Arrhenius acid has a hydrogen, and Arrhenius base has a hydroxide. The second definition of acids and bases are what we call the Bronsted-Lowry definition. And this is where we start really looking at the protons, that hydrogen. What is that hydrogen doing? If the hydrogen is donated, meaning that you have a compound that has hydrogen and it's willing to give up the hydrogen. If it can give up a hydrogen, if it can donate a hydrogen, then we call that a Bronsted-Lowry acid. So a Bronsted-Lowry acid is anything that donates a proton or a hydrogen. And then the base is just the opposite. The Bronsted-Lowry base will accept that hydrogen or accept the proton. And so if something gives up a proton, gives up the hydrogen, then it's an acid. If it accepts that proton or hydrogen, then it's a Bronsted-Lowry base. From the Arrhenius definition, that means all those acids, that hydrogen, it will give it up. And so that's also a Bronsted-Lowry acid, as we would expect. I mean, if you have an Arrhenius acid, it should also be a Bronsted-Lowry acid. Now, what about the hydroxide? In the case of the hydroxide, an Arrhenius base is something that contains a hydroxide ion. Well, Bronsted-Lowry bases do not have to have the hydroxide ion to be considered a base. And there are many examples of bases that do not have the hydroxide ion. The most common example is ammonia. Ammonia is NH3. NH3 will be able to accept a proton to make the ammonium ion, NH4+. In that case, the ammonia accepted that proton, so therefore ammonia is a base. So if you mix ammonia with water, ammonia is going to accept the proton from the water to make ammonium ion, and then the water is going to it's going to donate that proton. In this case, water ends up being an acid. And so ammonia is a Bronsted-Lowry base in this situation. Now, whenever you have a acid-base combination like that, in the case of Bronsted-Lowry acids and bases, you have what we call a conjugate acid-base pair. And so let's think about this. If you have HCl, so hydrochloric acid, HCl donates this proton. That's what makes it an acid. It donates the hydrogen ion. And so what's left over? The chloride ion, the Cl-. So the HCl is an acid. The Cl- will end up being the conjugate base of that acid. And so whenever you want to figure out a conjugate base, what you do is you take away the proton. So for HCl, the conjugate base will be Cl-. If we had another acid, let's say sulfuric acid. Sulfuric acid is H2SO4. We will take away one of the hydrogens from sulfuric acid to be HSO4. This time we'll have a minus because it makes it a negative. HSO4 negative is going to be the conjugate base of the acid sulfuric acid. So to figure out or to determine the conjugate base of an acid, all you do is you take away the proton, take away the hydrogen. And so you also have a conjugate acid of the base. So let's think of the base of the chloride ion. So if you have a Cl-, to get the conjugate acid, you add a hydrogen and to get the HCl. So if your base is Cl-, the conjugate acid is going to be HCl. Let's say you have the nitrate ion, NO3-. NO3- is a base. If you add a hydrogen to that, you get HNO3, which would be the conjugate acid. So to determine conjugate base, you take away the hydrogen. To get the conjugate acid, you add a hydrogen.